Okay, guys, let's do this. So we're still on fluid mechanics N5, right? So we have still doing question number 2. So this is the same sort of question, but in a different format now. So here we have a system in an aircraft. So they say it's hydraulically operated as follows. So we have a foot pedal that give the mechanical advantage of 2.5:1 is connected to the master cylinder, which has a 15 mm diameter piston. And the latter, when activated, operate the 20 millimeter diameter slave piston. The force requires at the slave cylinder is 850 newtons, and then the foot pedal may be depressed to a distance of 100 or of 70 millimeters. So the first question they said find the force required at the pedal to the operation system. And then number 2, they say find the distance which the slave cylinder piston will move when the foot pedal is completely depressed. So regardless of that of compressibility. So here is the how can I put this bidirectional. Okay. Yeah. So here it's the sketch. I tried to draw the sketch. Let me remove this page. Okay, so this is the simple hydraulic system. So now in this case it has a mechanical advantage. That means it's been added to what you call a lever system outside. So if you add this lever system, they say that this is a foot pedal. So when you apply a force on the foot pedal now to apply the brakes, so the brakes will then apply a force to the master cylinder. The master cylinder will then apply what? The pressure to the slave cylinder. So this is the system that that's happening here. So the force that is going to be applied on the foot pedal is the one that we call it an effort. So an effort, and then the one that is going to be applied now on what you call on the force of what you call the force of the master cylinder is going to be what you call our load. No? So this is still the load, or which is the force on the master cylinder. And we know that mechanical advantage is always load over effort, right? And then again we have this thing that says also mechanical advantage is equal to what? The effort distance, or the distance that is moved by the effort. So that means when you applied this force, they say this when you applied the brakes, the foot pedal will move what? A distance of what? Of 70 millimeters. That means when you apply DM, this one is going to move. This is what? So to completely apply the brakes this side, therefore you need to move the foot pedal what? 70 millimeters. This is what you call our effort distance over what? Over the load distance. So in this case, the load distance, because this is the load, and then the load that is the distance that is going to moved by the load now becomes what? Becomes your stroke length. Yeah. So this is the length on the master cylinder, becomes the stroke length. So now if you needed the stroke length, therefore you need to come back to this point. So you use what? Your mechanical advantage, which is 2.5, and then this is your the effort distance, and then you need the load distance. The load distance is going to be low. So There's nothing complicated with fluid mechanics or anything in science, no? So the only thing that you need to know, understand, is just you need understanding for you to be one, to be able to do such things. You see, this load, this mechanical advantage, this is something that we did on N2 and N3. This one, when you do what you call mechanical advantage and lifting something on N2, this one, right? So this is what is happening now. So the first question was our first question was to calculate on, where is it? Okay, yeah, to find the force required at the foot, at the foot pedal, at the foot pedal to operate the system. That means we need what? We need the force that is going to be applied here. We need what? The effort. So for us to get the effort now, we need, okay, we do have the mechanical advantage, but we don't have what? The load, which is the force on what? On the force on the master cylinder. So now we need to come back to this side. We need to solve it backwards to come to this point. We have the force on the slave system. So remember, we said the force that is applied on the master, the pressure is equals to the pressure on what? On the slave. So the force, which is the load here on the master cylinder over the diameter of what? Of the master cylinder squared, is equals to the force on what? On the slave over the diameter of the slave. So this to get what? To get this force. So therefore the force on the master cylinder would be equals to the diameter of the master cylinder squared multiplied by the force on the slave over the diameter of what? Of the slave squared. Okay, so this squared is the one that represents what? The area CM, right? I just remove what? The area. So because area is like this, nah? Area is like this. So we just cancel out this 4 and pi, so that we have these diameters, right? So because pressure is equals to what? We know that pressure is force over area. This is what is happening here. So now the diameter on the master cylinder, this is 15 now. So we can use 15 squared multiplied by the distance is going to be sorry, the force on the slave system is 850 over 20 now, and then you get your answer. So so it's going to be 15 squared times 800 over 20, so 20 squared, so it's going to be 478.125 Newton. No, so this is our force on what? On the load side. So I didn't convert this one into meters, because I know that the units here will cancel out both sides. But you for everything to be safe, always make sure that you convert your unit to meters, no, your millimeters to meters. So now this is the force on what? On the load side, right? So for you to get now the force on what? On the effort is going to be what? We're going to use mechanical advantage now. So that means effort now is going to be what? It's going to be load over the mechanical advantage. So therefore our load is going to be 478.125 over u2.5, and then you get what? You get the force on the foot pedal, which is what? 191.25 Newton. So 191. So this is what? This is the force that is required at the foot pedal to operate what? To operate the system. So that means this is the force that you're going to need here. So this force on the load, this one is what is your 478.12 5 Newton. So this force on the low on the effort is going to be 191.25. Okay, 25. So you get your first 4 marks, right? And then the second question now, they said find the distance which the slave cylinder piston will move when the foot pedal is completely depressed. So that means after pressing this foot pedal completely depressed to this line that I drawn here. So when you press this one also going to move. So remember, this one is it's depending on what you call on the volume now. So the volume, we say that the volume on the master cylinder is equal to the volume on what on the slave now. So the volume on master cylinder is what is actually pi d squared over 4 times the stroke length on the master equals to the pi d squared on the slave times 4 times the slave one length. It's like this. No? So what we need is this length, right? So this is what this is your also your things from N3. So we know that the volume displays or not on the master cylinder is equal to the volume displays or not on the slave cylinder. But this one, it always depends on the number of stroke. Here, sometimes if they say it after 2 pumping stroke, but in this case you only apply it once, the what you call the foot pedal, no? But if they added a stroke, therefore we're going to multiply by the stroke. So then you can cancel out this one, and then you say this L is going to be 1, S is going to be a pi d squared times Lm, which is this one, divided by d squared S. So now the challenge is on getting what this stroke length. So the stroke length, you said well, to get the stroke length, you can use what you can use also the mechanical advantage. This is the stroke length, right? We say in mechanical advantage is also the effort distance over the load distance. The effort distance is your 70, your load distance is what is the stroke length. So now to get to your stroke length, which is going to be going to cross multiply the effort distance divided by the mechanical advantage. That means it's going to be 70 divided by 2.5, and then you get then 70 divided by 2.5, you get to 25. So it's 28. So therefore this one's going to be 28 millimeters. Then now you can come here and then say your diameter, it's your 15 squared times this one is going to be 28 over this one is going to be 20 squared, and then you get your answer here. Simple stuff, very easy, very easy. So you need to know your concept or your basic thing. So that means this is 15.75 millimeters. So this is the distance that this will move after you compress it fully. This one, so distance. So it's your 5 marks here, right? And then let's get to this one. This one is a little bit serious, but it's nothing actually. So this is what you is your free play. Also it's the same as the previous one when they say calculate the free play. No, so the free play on this, it's always determined by the change in what in volume, so that you can get what the change in length. But now in this case, they said if 2% of air by what, by volume, is trapped, now this 2 and 8% is trapped in what, in the slave system, which contains what, 100 millimeter of liquid. So they say find the distance which the which the slave system which the slave cylinder piston will move when the pedal is completely depressed. Then assume that the bulk modulus of liquid is 1.8, and then this one is 1. You take this alpha as 1.4, right? So now in this case, your you need to calculate what, you need to calculate using this formula, right? So this is compressibility. So when you have compressibility, you have this K. You know that this K is the one that represent what, this K is the one that represent your compressibility, which is going to be equals to the change, or the strain, which is going to be equals to the change in volume, total volume, or it will be equals to what, the pressure over K, no? So this is E. This is E. So that this K as this one that you got it here, right? So now on this one, so remember this K, the first one, this one represent K for what, for the material. So this K Kc is for the material, is always the Young's modulus of elastics over 2.5. But now we are not given what, this Young's modulus, therefore we don't consider the one of the material. But this KL, now this is what, this is for the substance that we use here. So the substance that we use here is going to be what, the substance that we use here is the Young's modulus of elastic, the bulk modulus, which is what, 1.7. And then Vg, now this is the volume of what, of the air over the total volume. But then now we are given as what, as 20%. Oh, sorry, it's 2%. Therefore, okay, let's write it this down. I need to write it where everything will be visible at the same time. Okay, yeah. So therefore we have 1 K is equals to 1 over the other one at 0, therefore we'll just leave it as 0, plus now it's going to be 2 over 100 because it's 2% over, now this is going to be 1 over, remember we said kg. Now kg is always what, it's always the pressure multiplied by this one, this alpha, right? So the pressure multiplied by alpha, then we need to get what, we need to get our pressure, right? So our pressure here, you can take either pressure. Remember we said the pressure that is this side exerted on the master is the same pressure that is exerted on what, on the slave. So pressure is always equals to 1. Pressure is always force over area. So our force is what, let's take the force that we got it here on the master, on the slave cylinder. So it's going to be 850 times our pi d times what, times 0.02 squared over 4 times 1.4, because they say we need to take this alpha as what, as 1.4, and then we can get what, we can get this K. Substitute this K here so that we can get this one, right? So after getting this one, therefore we go to the change in volume over the total volume is equals to what, it's equals to it's going to be equals to the pressure over K. Simple as this. Simple. After this one, go to go to this one, say times the area on what on the slave system. Now, so now to get okay, we need to get this K. To get to this K is going to be equals to sorry. Okay, this K is going to be let's calculate it. I thought I calculated somewhere. Let me pause this. Okay, so our pressure will be equals to 2.706 times 10 to the power 6 multiplied by 1.4, right? So this will give us what? This will give us 3.787 megapascal, right? Megapascal. So let's just write it as 10 to the power 6. So therefore, put it here 3.787 times 10 to the power 6. Then close bracket. This one is 10 to the power 9 because this is mega. Sorry, it's giga. So therefore, to get this KE, now KE will be equals to this KE will be equals to 5.837 times 10 to the power minus 9. Therefore, KE will be equals to, then you just cross multiply here, and then it will be equals to 1.713 times 10 to the power 8. No? So this is your K. And then we go to then the next one. So now remember, here we're given the volume. They said the slave system needs to contain what 100 what cubic millimeters of volume or of liquid. So sorry, this one is supposed to be in cubic millimeters, not in millimeters, because this is volume, right? So it should be in cubic millimeters. So now you're going to have what this one here say that the change in area or change in volume will be what will be your pressure which is 2.706 times 10 to the power 6 times 100 now times 10 to the power negative 6, because it's millimeters to meters is 3 times 3. I'm sorry, 3 times 2. So it's going to be 10 to the power minus 6 over the side is your K, which is 1.713 times 10. So you see now the difference between this one and the previous one is that on this one we're not given the material, the K for the material, but we are given for air. This one is always for air. On the previous one, we are not given the air, but we have the material and the substance, right? So if you have the material and the substance and the air, you can use it the whole thing. But on this one, you only have what the substance and the liquid only. Sorry, the air only. Right, is to get this K, so that you can get what the free play that is here after compressing totally that side. Thank you for this chapter. then we're going to continue again. We're going to do four of this sort of questions. So the remaining two we'll do them tomorrow. But I will upload everything same time tomorrow as well.